Hello friends. In this video, we will dive into the inner workings of the JavaScript event loop. Understanding the event loop is essential for building efficient and responsive applications with JavaScript. JavaScript is a single-threaded programming language, which means that it can only execute one task at a time. However, it can perform tasks asynchronously, meaning that it can start a task and then move on to other tasks while the first task is still being executed in the background. This allows JavaScript to perform multiple tasks concurrently, improving the performance and responsiveness of web applications. Asynchronous tasks are handled by the event loop, which is a mechanism that handles the execution of asynchronous tasks. It is an infinite loop that waits for tasks to be added to the task queue and then executes them in the order they were added. It is a part of the browser's JavaScript runtime. It uses two important data structures to handle asynchronous tasks, stack and queue. Stack. A stack is a data structure that operates in a last-in, first-out, LIFO manner. It allows you to store and retrieve data such that the last piece of data you added, pushed, to the stack is the first one you can remove, pop. For example, imagine you have a stack named ARR, which is initially empty. If you push 1 to the stack now contains 1. If you push 2 to the stack, it will be on top of 1, so the stack now contains 2 and 1. If you push 3 to the stack, it will be on top of 2 and 1, so the stack now contains 3, 2, and 1. When we call pop method, it will remove 3 from the stack, because it was the last item added to the stack. Now the stack contains 2 and 1. Next, it will remove 2 from the stack, because it was the last item added to the stack. Now the stack contains 1. Next, it will remove 1 from the stack, leaving the stack empty. Queue. A queue is a data structure that operates in a first-in, first-out, FIFO manner. It allows you to store and retrieve data in a way that the first piece of data you added, enqueued, to the queue is the first one you can remove, dequeued. It's like a line of people waiting to get on a roller coaster. The first person in line is the first to get on the roller coaster. The last person in line is the last to get on the roller coaster. Let's look at an example. A queue has enqueue method to add an item to the queue. It's similar to the push method in the stack. Now if we call the dequeue method, it'll remove the first item from the queue, because it was the first item added to the queue. Next, if we call the dequeue method again, it'll remove the second item from the queue. Then, it'll remove the third item from the queue. Now we have a good understanding of stack and queue. Let's see how they are used in the JavaScript runtime. JavaScript runtime contains a call stack, web APIs, callback queue, and event loop. 1. Call stack. As the name suggests, it's a stack that stores all the functions that are currently being executed. 2. Web APIs. It's a browser APIs that are used to handle asynchronous tasks like setTimeout, promise, fetch, etc. 3. Callback queue. It's a queue that stores all the callback functions that are ready to be executed. 4. Event loop. It's a mechanism that checks the call stack and callback queue and moves the callback functions from the callback queue to the call stack when the call stack is empty. Let's see JavaScript runtime in action without any asynchronous tasks. I've created 3 functions, foo, bar, and baz. When we call the baz function, it'll call the bar and the bar will call the foo function. When the baz function is called, it'll be added to the call stack. Then bar function is called. It'll be added on top of the baz function in the call stack. Similarly, the foo function is called, it'll be added on top of the bar function in the call stack. Foo function has only a console log, which will be added to the call stack first, and then executed and removed from the call stack and log 1 to the console. Then foo function will be removed from the call stack, which doesn't have anything to execute. Now bar function is on top of the call stack. Execution of bar function will now move to the next line, which is the console log function. It'll be added to the call stack first, and then executed and removed from the call stack and log 2 to the console. Because bar function doesn't have anything to execute now, it'll be removed from the call stack. Now baz function is on top of the call stack. Execution of baz function will now move to the next line, which is the console log function. It'll be added to the call stack first, and then executed and removed from the call stack and log 3 to the console. Because baz function doesn't have anything to execute now, it'll be removed from the call stack. Now let's see JavaScript runtime in action with asynchronous tasks. I've created 3 functions, foo, bar, and baz. All functions are independent of each other. But now we have a setTimeout function added in the bar function, that will be executed after 500 milliseconds. When we execute this code, the first foo function is called and, it'll be added to the call stack. It only has a console log function, which is first added to the call stack, then executed and removed from the call stack, logging 1 to the console. Then foo function will be removed from the call stack, which doesn't have anything to execute. Now, bar function is called and it'll be added to the call stack. It has a setTimeout function, which is first added to the call stack and then executed. Because setTimeout function is asynchronous, it'll be added to the web APIs and removed from the call stack. Then bar function will be removed from the call stack, which doesn't have anything to execute. Now, baz function is called and it'll be added to the call stack. It only has a console log function, which is first added to the call stack, then executed and removed from the call stack, logging 3 to the console. Then baz function will be removed from the call stack, which doesn't have anything to execute. When the 500 millisecond timeout expires, it will be added to the callback queue. The event loop checks the call stack and callback queue. It'll move the function from the callback queue to the call stack because the call stack is empty. Then the function is executed. It'll log 2 to the console and removed from the call stack. This process continues indefinitely, allowing the JavaScript runtime to efficiently execute asynchronous tasks while also maintaining a single-threaded execution model. I hope you enjoyed this video and found it helpful. If you did, please consider liking and sharing it with your friends and subscribing to my channel. This will help me create more content like this in the future and allow more people to benefit from it. Until then, happy coding!